Good day to the judge, fellow participant and esteemed guests. We are proud representative from Polytechnic Kuching Sarawak under the Department of Petrochemical Engineering. Today, we are here to present our research project entitled Polymer Ceramic Membranes for the Photocatalytic Treatment of Oil Removal. This project focused on developing an innovative water treatment system using PVA as a polymer, ceramic as a choline as a ceramic, and UV activated TiO2 photocatalyst to remove oil contaminant from water. We hope this solution will benefit not only communities but also industries and future researchers in the field of environmental engineering. Let us now begin our presentation. First, myself is Muhammad Aziz bin Osman, who focused on the ceramic component, particularly the role of choline in the membrane formulation. And next is Maximus Kebimbili, who conduct experiment related to UV intensity and its effect on photocatalytic oil removal. Then Muhammad Fauzi, who is in charge of the polymers material development for the membrane structure. And lastly, our Nabil Izatul Hazim, who analyzed the impact of membrane bed head in the reactor system. Together, we form a collaborative team with a shared goal of enhancing water treatment technologies through innovative membrane design. And this is our agenda. For the background project, photocatalytic membrane reactor PMRs consists of a system that integrates photocatalyst with a membrane filtration. Glue as a polymer plus choline as a ceramic plus TiO2 as a photocatalyst make our membrane.
Hello, my name is Maximus Kebimbili, and I would like to present to you about the mechanism schema of degradation of organic pollutants in titanium dioxide, that is our photocatalyst. So in this photocatalyst, there's a valence band and conduction band. So when there's a solar radiation, it will activate the photocatalyst and it will create electron hole pairs. So this electron hole pairs is highly reactive that will react with anything. So for example, let us use cooking oil. So this cooking oil has hydrocarbon molecules. So when it goes through the photocatalyst, it will break down the photocatalyst into non-harmful materials such as CO2 and H2O, that is carbon dioxide and water. I think this is all for the mechanism schema. So right now I would like to present to you about the problem statement. So as you guys may know, there's 88.4 million barrels of oil have been produced daily in 2023 and 2020 respectively worldwide. So the widely used methods for the treatment of oily wastewater are electrocoagulation and electrophoretation. So these two methods is effective for oily wastewater treatment, actually achieving over 90% removal efficiency with less chemical dosage and producing more compact sludge compared to chemical coagulation. However, it has its disadvantages such as electrocorrosion, requiring frequent replacement, energy-intensive operation, sensitivity to parameters like current density and oil concentration, and longer treatment times for higher oil loads. So additionally, sludge volume increases with oil concentration, and fouling or passivation of electrodes can reduce efficiency. These factors make process optimization and maintenance critical for practical application.
For the objective, for myself, to study the effect of membrane ceramic ratio on oil removal, and for the Muhammad Fauzi, to study the effect of the membrane polymer ratio on oil removal. For Maximus Kebimbili, to study the effect of UV intensity and on oil removal. For Awang Nabil Izatul Hazim, to study the effect of the membrane bed height on oil removal. Scope and significance of study. My constant variable is oil volume, amount of water, and TiO2, duration of TiO2 coating 50 minutes, and watt of UV radiation 160 watt, and permeation time 2 hours. For the manipulated variable, mass of choline. Responsible variable, the percentage of oil removal.
Good day, ladies and gentlemen. My name is Muhammad Fauzi, and I will explain about the polymer section. I will be presenting the polymer section of our project. First, first, we use glue as a PVA, polyvinyl alcohol, bought from supermarket nearby our campus as the polymer material for membrane fabrication. The polymer was mixed with water and kaolin using the slip casting method and then dried at room temperature for 24 hours. Polymers provide mechanical strength and chemical stability to the membrane. In our absorption test, the polymer showed high oil absorption capacity, making it a crucial component of the membrane in enhancing oil removal performance.
Hi, my name is Ong Nabil, and for my scope and significance of studies, for my constant variable is all volume, amount of water, and TiO2, duration of TiO2 coating, weight of UV radiation, and permission time. And for manipulated variable is membrane bed height, and for responsive variable is oil removal.
So now I would like to present to you about the scope and significance of study. So for constant variables is the same as the other. So as for my manipulated variables, mine is the distance of the UV from the membrane. So the UV light is placed above the membrane. So this is a different level with different heights. So from this, I want to know whether if it's nearer to the membrane, is it effective or not? Is it uh, far more effective? If it's like if it's higher, if it's more effective, or is if it's low, if it's more effective. So this is for my manipulative variables. So as for the response variable, it is the percentage of oil removal.
Hi, my name is Mohammad Fauzi. I will explain the scope of project. This project is focused mainly on the oil removal as a pollutant. In this study, the synthetic wastewater is prepared using cooking oil and water. The kaolin clay as the ceramic is obtained from the market, and the glue as a polymer is bought from supermarket nearby the Polytechnic Kuching Sarawak. This study is intended to investigate the effect of the ceramic polymer membrane ratio, UV intensity, and bed height of the membrane on the oil removal percentage. Next, I will explain the significance of study. For the society, providing cleaner water resource, ensuring access to safe and sustainable water for communities. For industrial players, enhancing operational efficiency and cost effectiveness. For industry, more sustainable and efficient method for wastewater treatment, where future researchers have to refine and expand studies in the field of water treatment technologies.
First of all, we draw the reactor in AutoCAD, and after that, we construct a prototype for the PMR and do some experimental work, such as effect of ceramic ratio, effect of polymer ratio, effect of UV intensity, and effect of membrane bed height. And after that, we collect data and make a calculation of the oil removal, and we make the data analysis from the calculation of our oil removal. And for method preparation of TiO2 suspension is using mixing 20 gram of TiO2 plus 200 milliliter of water and 4 milliliter of acetone. And we let it dry for 30 minutes at 350 degrees Celsius. And for the production of membrane, we use a 30 gram of kaolin, 30 gram of polymer, and 30 gram of water. And we use a slip casing method. And after that, we leave it at the drying at room temperature for 24 hours, and we sinterate at 150 degrees Celsius for 1 hours. Characteristic of the product: kaolin clay, excellent mechanical stability, chemical and thermal resistivity, and good mechanical strength, and high absorption capacity. And for titanium dioxide, simultaneously undergoes surface modification and photocatalytic self-cleaning anti-fouling process. One of the main characteristics of TiO2 is its ability to undergo photocatalysis under UV light exposure. And for the UV intensity, UV ray also have a strong disinfect effect which can kill or inactive pathogen microorganism in waterways.
And this is our HIREC and SDS. Okay. Our budget and financial management. This is final result and testing analysis. As we can see, this is how we calculate our final oil weight, oil removal percentage, and mass convert to volume. Now, I will explain the final result for the choline ratio testing. From this table and graph, we can see that the highest oil removal efficiency was achieved at the ratio of 3.3.3 with 95.55% of oil removal as highlighted in green. To achieve this result, I tested various ratio of choline, polymer and water. What I discovered was, as we increase the amount of choline, the membrane structure become denser, which improve the adsorption surface area and allow better oil removal. However, when too much choline was added, the membrane start to become brittle and fragile. This means that although choline improve oil removal, there is a limit to how much we can use. If the ratio of choline is too high, the membrane loses its mechanical strength and become unstable. So, I had to balance the composition of choline with enough polymer and water to create a membrane that is not only effective in removing oil but also physically durable and reusable. In conclusion, the optimal ratio for both performance and stability is ratio of 3.3 to 3 to 3.
My name is Montwazi. I will explain the final result of my experiments using polymer. This presentation explores the use of PVA as a material in photocatalytic membrane reactors with a focus on composite ratio of 4:5:3, which demonstrates the highest oil removal efficiency of 98.75%. The study highlights how PVA-based membranes, when combined with an optimal photocatalyst and support structure, offer a promising solution for treating oil contaminated wastewater. PVA is a synthetic polymer, widely recognized its film-forming properties, excellent water solubility, and compatibility with various photocatalysts. Its hydroxyl-rich structure allows it strongly bind with other materials, making it an ideal matrix for composite membranes. In photocatalytic reactors, PVA serves not only as support materials but also helps to enhance the overall mechanical and chemical stability of the membrane. Thank you.
Okay, based on the final result and testing analysis that we got from the experiment, the graph show that the thicker the membrane is, the better for the oil percentage removal.
So right now I would like to present about the final result and testing analysis for UV light distance. So for the first distance is 6.5. So for the next level is 8.5. So I would add on 2 centimeter for each the level. So for the oil weight for each experiment is the same. So for the empty beaker, it will be different because for every experiment I use different beaker. And the beaker weight with oil after heating to remove the moisturize, so to remove the water that help the oil to get into the to our reactor. Sorry. So for the final oil weight, I will subtract the beaker weight with oil after heating, subtract it with the empty beaker weight. So next I will convert it to the volume, that is milliliter. So the highest oil percentage removal is 6.5 centimeter distance. So this one shows the highest percentage removal for the distance. So as for the conclusion, the nearer the UV light to the membrane, the higher the percentage removal for the photocatalytic membrane reactor. I think that is all from me. Thank you.
This is absorption rate of kaolin. And this is absorption rate of polymer. And for the conclusion, in conclusion, our project demonstrates that a well-designed membrane reactor combining polymer and ceramic material, UV activation, and optimized bed height can effectively remove oil from synthetic wastewater. This system offers a sustainable, cost-effective, and eco-friendly alternative for wastewater treatment beneficially for society, industry, and future research. Thank you for your time and attention. That's all from us.